Okay, welcome back. Um, so today we start and actually finish the slides for chapter 6. So chapter 6 is comparing two means. If you know where we're coming from, chapter 5 was comparing two proportions, and now it's going to be like that. We'll cycle between means and proportions. So chapter 6 is now comparing two groups, but it's means that we're interested in. All right, so that's the setup. So again, I have a pretty simple data set to understand. So now I have a random sample of US adult gun owners. So these are all gun owners already. See, the previous data set we are interested in has at least one gun. So some people didn't. Okay. But this one is talking to gun owners. And so you measure two things on each gun owner. First, you have the sex of the person, male or female. And the other variable is how old each person was when they owned their first gun. Now, this question makes sense to the people in the study because they are all gun owners already. So they asked them their sex and how old they were. So let me ask you the first question. Of these two variables, which one do you think is the most natural to be the one that puts people into buckets? Yes, the sex. I agree, right? It's kind of weird to put this as the bucket because how many buckets would you need? Okay, so sex, which means and sex is categorical. Okay, so yes, and then the other variable therefore would have to be the response. How old each person was when they owned their first gun. Is this kind of variable categorical? Like if you ask someone, how old were you when you owned your first gun? What kind of answer would they give you? They'll give you a number, which means it's quantitative. Now, can age groups be made categorical? Yes, but that's a story for another day. In this data set, we are not asking people which age group are you in. Sometimes questionnaires like to do that because people don't have to reveal so much about themselves. But this is not that kind of data set. This one recorded the actual age when they own their first gun, and therefore it is not categorical, it is quantitative. This is why, because the response is quantitative, that is why we are interested in a mean. If the response is categorical, do you own a gun? Then you're interested in a proportion. But here, you're interested in a mean because your response was quantitative. Okay? So it says the next slide, write down the values of X bar men, X bar women, S men, S women. So I'm going to do this interactively. You haven't seen the data set yet. I am going to do this. So the data are actually, I have a copy of data, obviously. So I'm going to put it on the class. I'm going to put it on our class Scratchpad. So our class Scratchpad has, okay, I'm adding a sheet here. So I'm going to call this gun age. Okay. Okay, so you should be able to access the data now. This is in your section 11 data Scratchpad. Go to gun age. Here's the data. You can see male, 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 and how old and all that. Okay, so we have that. Here's what I want you to do, and this is revision. Does anyone remember the code for how to compute these four things? Can you give me X bar men, and I'm not writing out men in full, it takes too long, X bar women or female. Can you give me S men and also S women? Does anyone remember the code that you need to compute these sample statistics? If you do remember, then you can contribute to this one. Because the slide asks you to report these statistics. I'm giving you the data. The data are here. How do you use Google Sheets to find means and standard deviations? Do you remember it? Does anyone remember the function that you need to use in Google Sheets to get, first of all, to get a mean? Anyone remember? I made a video about this, so if it's anything, if it's hazy for you, just go watch the videos on. It's the link is on Moodle. Does anyone remember what function Google Sheets uses to get a name? It's a particular word. Yes, good. So you need to go. Yes. So now what you need to do is don't alter this cell. Go to a fresh cell here Height equals F. Now, is ADG the correct code? What was it? Right? This is important. So you might want to write this down because AVG is Google Sheets doesn't understand. So do you remember the thing that I yes, average. Remember? Average is the correct word. Oops. Okay, so you go there, that's right, equals average, parentheses open, then you select the cells that you want to find the average for now. We want only the male mean, so only select the male ages. Can you do that? All right. Now, does anyone remember how to get the standard deviation of data? What is the function, the word that you need to use? If ever you don't remember, just Google it, right? How do you find the standard deviation using Google Sheets? Google to get something about Google Sheets, right? Google will tell you. Anyone remember? These are important because I think if you leave a intro tech class and not know how to do these things, I don't think I've done what I set out to do. Does anyone remember the code for standard deviation? You can check online if you want. How do you find the standard deviation for a data set? These are correct, by the way. This is the male mean, about 20 years old. This is the female mean, almost 30 years old. All right, good. Anyone remember the code for standard deviation? Yes, STDEV. Remember STDV? That's right. These are important, write it down. Because, most of us will go on after college to work, and you might be asked to do these things. It's going to be pretty embarrassing to not know this, or not know how to search for it online either. So take note, okay? These are very, very fundamental, so I think it's quite important to know how to do this. If you want to see what code was used, just go to that cell and you can learn from the correct code there, right? You can see the code that someone used. Yes, that's right. Good. Okay. One last thing. Does anyone remember how to draw a histogram? And by the way, you can fill this in your slides. That's your X bar men, X bar women, S men, S women. Can someone generate a histogram for the man? Does anyone remember how to do that? Again, I've made videos for all these things. Let's see. Okay. Histograms are not bar charts, okay? So just make, do you remember how to do it? All right, give it a try. It's quite basic, this one. You don't even have to choose the right chart. It is smart enough. As long as you remember to select your data before you insert anything, select the data that you want a chart for. It is smart enough to know what chart to draw. All right. Does anyone remember? I have mentioned this in the past. I made a video as well. I don't know whether you viewed it, but if you are in any doubt about doing these things, it would be good for you to revise how to do it. These things are important. It's not just about statistics. It's not just about inference all the time. I want you to be able to make displays as well. Does anyone remember? Okay, let's see. All right. Okay, this is a good try, but is this a histogram of the data? This is a bar chart of the four statistics. It's not what I actually want. So I think you all are not very clear on what I want exactly. So this is not the right chart, all right? But thank you. That chart is just plotting these statistics. You could do that, but it's not what I want. I want a histogram of the ages, a histogram of the ages. Do you remember this? I give you a hint. Select the cells that you want to make a histogram for. All right. Select the cells. Let's start with male. Select the male ages. Then does anyone remember what you need to do? You have to click something. It's on the screen. What button do you click when you want to make a histogram? You have seen me do this. Maybe not enough time, so you can't remember. Anyone at all? Remember how to do this? Thank you. Did you hit insert? All right. So what you do is, so okay, thank you. So this, and if you want, you can alter the title. Just say, okay, something like that. So it's a little bit more meaningful. All right. I'll shrink it. So I will show the class how this was done. Okay. This is the male histogram. How do you get a female one? Okay, thank you. So the female, good. So the female one, you just do this. I'll just show you. I won't click anything. I'll just show you. You just select the female cell, female ages, insert. It's literally click two things, three things. Select cells, insert chart. That's it. It really, maybe in the future you speak to the computer. I want a histogram of these, and then it will come out. Maybe, but the day is not today yet. Maybe one day it'll be like that. It's already fantastically foolproof already. Insert chart. Select cells, insert chart, the right chart appears. All right, good. So that's your female histogram. So let's go back to our slides. All right. So we have X bar men, X bar women, S men, S women. You have recorded those. Define mu men. Now, I want to ask you this. Every time you see a parameter, I hope you realize it's a parameter. First of all, you have to give me words. Right? This is not a sample statistic because this is a Greek letter. What are the first words that should come out of your mouth when you see a parameter? Yes, the long run. In this case, this is a long run what? Mu represents a mean. This is the long run mean. Now, every time you write the word mean, the word that follows mean should be a quantity. Don't say the mean of men. Oh, that triggers all the physics professors. The mean of men. Yeah, what about the men? Right? What characteristics? So the mean. What is the quantity that we're interested in here? The long run mean. It is something to do. The word man is going to appear in the definition, but mean what? What have we been talking about for the last 13 minutes? What about the guns owned by men? What feature is of interest here? The long run mean age of men when they own their first gun. Did you get that? So let me tell you the process of how you define parameters properly. First of all, every time you see a Greek letter, it is going to be a word definition. The word long run or true must appear. Long run or true, whatever you like. The long run, this is mu, so it's a mean. Every time you see the word mean, you must have a quantity after that. Don't say the mean of men. That statement just makes makes professors crazy. The mean of, yeah, what about the men? You can have the mean height of men, the mean weight of men, the mean salary of men, mean age of men when they got their first gun, something like that. So remember, the word mean must always be followed by a quantity. All right, and that's it. The long run mean age of US male gun owners when they own their first gun, something like that. I'm sure you know what mu female will be. All right. Let me ask you now. Can you tell me what you think the null hypothesis is going to say? I want you to base this off chapter 5. In chapter 5, when we compare two groups, also male and female, we say pi men equals pi women. Can you guess what the null says for means? We have mu men, we have mu women. What do you think the null says? Base it off chapter 5. In chapter 5, you said pi men is pi women. Anyone want to guess what does the now say in chapter 6? You manage new women, yes. These guessing questions, right, are very low stakes because you can't get it wrong. I'm asking you to guess. But if you said mu men equals mu women, you will be correct. The now says the same thing like in chapter 5. Status quo is that men and women, on average, own their first gun at the same age in the long run. Now, this may not seem sensible to you, but that maybe that's the part that makes people trip up about the null hypothesis. This is status quo. You always start from status quo, and status quo says status quo is the one with equal sign. Status quo says there is no difference between men and women when it comes to how old they are when they own their first gun on average. That's what status quo says. We are here to show whether this one should be rejected or not. All right. So the whole idea of statistics is, although the status quo may not seem reasonable when you look at the data. I mean, our sample mean age for men was, I think, what, 20 years old. For women, it was almost 30 years old. It's almost a 10-year gap, age gap. So it may not seem reasonable, and that's kind of the point of statistics. We want to use statistical inference to see whether we have enough evidence to reject this null hypothesis. That means, in other words, this is not something reasonable to say. But you start off with a status quo statement with an equal sign. So this, when you study chapter 6, make sure you compare it to chapter 5, right? Because they are very similar in their concept. All right? So this is exactly equivalent. Now, look at the alternative. I'm testing whether mu men is less than mu women because I want to. There are 3 possible alternative hypotheses. Less than, greater than, not equal to. That's the same thing. This is exactly, of course, equivalent to saying mu men minus mu women is 0. Or mu men minus mu women is less than 0. These statements are equivalent to those statements. Again, I'm writing it in this form because we are going to be focused on differences in this chapter. Differences. So I want to phrase that thing as a difference. Are you tracking what I'm doing so far? Is this okay? Right? You have done all this in chapter 5 for proportions. This is for means. The only thing that has changed is the response is now quantitative. All right? Okay. Let me now ask you, we are going to be learning a theory-based method. You know as well as I do now, every theory-based method you have to check some validity conditions before you can use it. Does anyone know what they think these sound like? You need at least, what's the correct phrase here? You need at least 20 observations, good. And those observations, when you plot them, not skewed. That's right. That's why I asked you to make the histogram. Now you just add on some words. Yes, it is. You need at least 20 observations, and both for both groups. It's not just for one group. See, the both is there. What was true for one group now has to be true for 2 groups. You need at least 20 observations in both groups. And all those observations, when you plot a histogram, should not appear too skewed. Let's, for now, just ignore the screen, the bottom part. I want to show you our histogram. Is this fulfilled? Look at compare the 2 histograms and see. Look at the male histogram. Is the male histogram skewed? Quite. It skews young, actually. The female histogram is not so skewed. It's more symmetric. So we have a slight violation of the VCs. Did you see that? That's what we mean by not too skewed. You actually need to make a histogram, and that is why I wanted to revise with you how to make a histogram. So you look at the histogram and you see, oh, this is quite symmetric, a little bit skewed, but not as bad as the male one. The male histogram is quite skewed, all right? Like that. Okay, so let's continue. We again can calculate a theory-based statistic. This theory-based statistic is called theory T, which should tell you that the correct table we should be using for everything is which table, Z or T? T. If I call it T and ask you to use the Z table, I'm crazy. Right? Why would I do things like that? So this is another standardized statistic. It's T because it involves means. Every time something involves means, it's T. Every time something involves proportions, it is the Z table. Now I want you to stare at this for a bit. Again, this should be quite familiar. Remember when you had one mean? You had X bar, no groups. X bar minus mu over S over root n. Do you remember roughly that formula? That was for one group. Now you're comparing two groups, men versus women. Can anyone tell me why? See, and again, the plus is correct, so be careful. Is this correct? Can't tell you why, right? But this is correct. I will talk about this in a minute, right? Let's leave that first. This is some kind of standard deviation. Can anyone tell me why? And I've asked this question in chapter 5 as well. Why do you think I put a 0 here? What is it to remind you of? Does anyone know the answer to this question? Why do you think I put a 0 here? You don't have to. When you calculate these things, you don't have to because subtracting 0 does nothing for you. But does anyone know why? This is a pedagogical device. It's for teaching. Why do you think I put a 0 here? Does anyone know why? This is just to help you learn stuff. Every time you form a standardized statistic, you have something that you see. Remember, red minus blue. Blue is status quo. So why is there 0 there? What is the 0 reminding you of? Anyone know the answer? Yeah, I think I heard it. I think I heard the right word. What is the 0 reminding you of? The status quo. What is the status quo? Good. The status quo is saying what? The status quo is what the null says. And the null says what? Mu men minus mu women is 0. So what am I doing here? I'm trying to show you that this is no different from any standardized statistic you've done. Observe, you can see these, status quo. Observe minus status quo. But the status quo now is a male versus female status quo. Because the statistic of interest is male versus female. All right? So let me tell you something. This T statistic is the most famous test in all of statistics. In fact, I believe it is the only statistical test that some people know. It is the most famous, number one. It has a very unassuming name. It's called the two-sample t-test. Now, you should write that down. I don't have it in my slides. This is called the two-sample t-test. Why is the name important? Because I don't want you next time, someone asks you to perform a two-sample t-test. I don't want you to say, oh, I don't know what that is. That is not true. Today, on March the 4th, I'm telling you, this is called the two-sample t-test. Sometimes we don't emphasize the names enough. We are so concerned with teaching you how to do stuff. This is called the two-sample t-test. So if anyone ever tells you go do a two-sample t-test, they mean this. Okay? So don't bring shame on our institution. Okay? Well, this whole grade doesn't know the two-sample. No, that's not true. Right? Professor Ko told you, right? This is called a two-sample t-test, and you are learning how to find it. All right. Sometimes you don't emphasize names enough, so I'm just telling you the name. It's very famous. The most famous test in all of statistics. Okay. Now what is S-food? Okay. I'll give you some time to copy this first. Yeah, I'll give you some time to copy these first. I'll show you where the numbers came from. Somehow, this statistic drives a lot of students crazy. I don't know why. It's a lot of arithmetic. Yes, the formula looks quite intimidating, but it's not that bad if you know how to understand it. So you copy first. Right? You copy down the numbers, or take a picture. Up to you. All right. Then I'll talk a little bit about why this statistic is defined the way it is. Now, a few simple things first. Let's get the numbers straight. Do you agree that the number of men in the sample was 40? If you go back to Google Sheets, you'll find that there are 40 men. You will also find that there are 35 women. So, of course, 40 minus 1 is 39. 35 minus 1 is 34. So, we have those. Right? You have to understand that. So, these are the two sample sizes, the two groups, less 1, less 1. And of course, if you take 40 plus 35 minus 2, you get 73. So that explains it. Do you understand the S men, S women? Do you see these on Google Sheets? What was the standard deviation for men? 2.17, right? I'll show you. See? 2.17 is the SD of the men. SD of the women, 4.199. Like that. So that's where those came from. The rest is just a lot of calculator. So this minus 1 times this 1 squared plus this minus 1 times this 1 squared over this plus this minus 2. So a lot of arithmetic. I'm going to tell you a few things about S-food. First of all, the name suggests what? S-pooled means you pool the information about S from the different groups. You pool the information about S from the different groups. This is some kind of overall spread. Remember P hat pool, that was an overall rate? This is an overall spread. And the overall spread takes contributions from all the groups. Okay. So this is why the formula is defined this way. However, so one way to know that your answer makes sense is this. So listen up. If you look at your S pool value, 3.276 here, this number has to lie between the smaller s and the larger s. See, the smallest standard deviation for the men was 2.17. The smallest standard deviation for the women was 4.199. As long as you calculate something that's between these two, not the square, the value of S pool must lie between the values of S that they contributed from the sample. If you see that, you kind of know that your calculation is probably correct. If you find that your answer is 7 or 8 or something like that, it's bigger than the original S values, that's wrong. It cannot happen. That's one fact. The second thing I want to say about S pool is this. This formula is interesting. This is actually a weighted average of the squares of the standard deviation. Now, why do I say weighted? A group that is bigger, has a larger sample size, has more say. It contributes more to S pool. And so I don't know whether you follow American politics. Some people do, some don't. Do you know that we have two chambers in Congress? There's a House and a Senate. This formula represents the way House seats are allocated. I'll tell you what. Larger states have larger N, more people. They have more seats in the House. California has way more seats in the House than Wyoming does. So they have a larger contribution to S food. You can think of it that way. The Senate in this country does not function that way. If your state is small or big, every state gets 2 senators. You know that. I think you know that. All right. Therefore, the formula that the Senate would use would not have something like this. It will not scale these things by the sample size at all. It won't. It will just take equal parts from all the different groups. Did you follow what I'm trying to say? So S pooled is trying to give more say to groups that are larger, which makes sense. You have a larger group, you have more information, you should contribute more to the value of S pool. right? So it's kind of like what's going on with the House and all that in this country. They try to give more representation. It's the House of Representatives, after all. They try to give more representation to larger states. Okay, so we have this as full formula like that. The other thing I can illustrate is, do you all know how Hope calculates your GPA every semester? Maybe some of you don't really know. So I'll explain. I know most Hope courses are 3 credits now. There was a change. Now, whether you like it or not, it's one of those. I don't even know whether it's a very divisive issue. I think one of my students, believe it or not, last semester did a project on exactly this. She gauged satisfaction levels about the 3 credit system. That was a fantastic project for the end of semester, and we found statistically significant people didn't like the 3 credit system. But anyway, the point is, when you have a credit system, let's go back to the old days, maybe before your time. Some courses at Hope were 4 credits, some are 3, some are 1, some are 2. What does that mean? If you get an A, first of all, an A in any course is worth 4 points. I think you know that. An A is worth 4 points. If you get an A minus, it's 3.7. Now, how does the credit for the class factor in? I'll explain. If you got an A for a class, you get 4 points. If that class was a 3 credit class, you take the 4, you multiply by 3. Keep that. Now let's say you had another class, you got an A minus. So that's worth 3.7. But that class matters less. It's only 1 credit. So you take your 3.7, you multiply by 1. That's exactly what's going on when you calculate GPA. You take your course score, scale it by the credit hours. I'm giving you so many illustrations to show you S-Pool is a scaled version of all the contributions of the standard deviation, giving more weight to larger groups. That's it. That is how you find S-Pool, okay? So other than that, it's just a whole, if you didn't like anything that I just said, it's okay. As long as you know how to find the answer, you're good, okay? So that is S-Pool. You take all these numbers and put it in, and you have your classic T statistic. Now, I hope you realize, isn't this a massive, massive standardized statistic? It's like 12. Okay, so therefore, do you think the p-value is going to be ultra small? It's going to be ultra, ultra small. Okay. Now, because this is a t statistic, to get the p-value, you use the t-table. No surprise. Now, let me ask you, do t-tables have degrees of freedom? So, yes. What do you think is going to be the rule for the t-table degree of freedom here? This one, I'm just going to ask you to completely just guess. Anyone? Don't worry, you can't get it wrong. It's a guess. What have you learned about degrees of freedom? How do you think you would change the answer now that you're comparing two groups? Anyone? Or maybe I'll ask it this way. What was the degree of freedom when you had only one mean? N minus 1. So I'm going to ask you to really give a good guess. How do you think that is going to change now that we are looking at? Very good. Okay, you're almost there. See, that's why I like students to guess first. It's n men plus n women minus 2. You take all the people that you have and subtract 2. Make sense? Another way to think about it is total up everyone and subtract the number of groups. You add up everyone and subtract the number of groups. That is why previously it was n minus 1. You have n people last time. You subtract 1. There was only one group. Well, now there's 2. So you add up everybody and subtract 2. Now, if any DF is unavailable, what have I told you to do? Round down, good. Yeah, I sometimes if any DF is unavailable, shut down the computer and stop your homework. No. If any DF is unavailable, you round down. Now you will find the p-value is very, very small. I will show you. Please make a correction. You can say something better than this. The p-value is less than 0.0005. Can you change that? It's less than 0.0005. I don't know whether when I made these notes, I was using a different table. You can be more precise. It is really small. I'll show you why. All right. If you go to our course page, you can see our T table as usual. Here it is. Okay. So what did we learn? We need a DF first of all. Now I think the number of men plus the number of women is 75. 75 less 2 is 73. Of course, 73 is not here. You round down to what? 60. Good. And you round down to 60. So I'm going to highlight 60 and all that. Now, do you remember how to find p-values? You look at the numbers here. 1, 1, 2, 2, 2, 3. Okay. Where's 12? Here. What does that mean? It means 12 is so far out. 12 is so far out. The area is extremely small. The area is going to be less than 0.005. It's the same thing like what you've done in the 1 mean case. Nothing new. The t statistic is so big that it is way outside the range. All we can say is the area. Look at the picture. The area is going to be less than this number. So that's why I said make a correction to your slides. It should be less than 0.0005. Right? Okay. Any questions about the T table? Any questions? Is it okay? Okay. What about confidence intervals? I hope you realize the confidence interval that we want to make is for men versus women. Notice it is for a difference. I want to make a CI for a difference. Just like in chapter 5, it was for a difference in proportion. Now it's for a difference in mean. Does it make sense to you that because I'm trying to say something about mu men minus mu women, I use x bar men minus x bar women as my midpoint? The same thing applies. Midpoint, something in the middle, plus or minus multiplier times some standard error thingy. Now the standard error gets complicated. I know. As the situation changes, the standard errors can change. That's why you have a cheat sheet. That's why I ask you to make cheat sheets. I don't want you memorizing things. Okay? So you have your observed. Why are we using x bar men minus x bar women? Because we want to CI for mu men and mu. You want to say something about the long run mean of men's ages minus the long run mean of women's ages. I'm going to say this phrase again. I've said this already. What else would you use? There's nothing else to use. You want to say something about men versus women and the means? Use the sample means to put those in. All right. If you look at this, do you see that the ingredients for making the confidence interval are suspiciously similar to the ingredients used to calculate the t statistic that we were talking about? This is exactly like different kinds of pasta, fettuccine, linguine, vermicelli, whatever. They are all basically the same thing, just different shapes. So the same ingredients can be used. All right. Or the boxes of cake mix and all the yellow cake. Yeah, you can take a yellow cake mix and make all kinds of cakes, but basically the ingredients are the same. Where do you think the multiplier comes from? Which table? Okay, good. Not that small chart I gave you, because this is not a proportion problem. So the multiplier comes from the T table again. The degree of freedom is the same thing. N men plus N women minus 2. If any DF is unavailable, you round down. And therefore, this is the computed confidence interval. Did you get that? I'll show you. X bar men, X bar women, multiplier. We'll get to that. Multiplier. S pool. I know it's like I don't know whether you're familiar. If you play computer games, You have to collect things in the different levels, right? You have to take, especially if you play those games set in the past. Collect one pot of gold here, collect a suit of armor here. So it's something like that. You have to collect different elements like a game. Expel men, expel women, multiplier, S pool, sample size, sample size. Of course, this is just arithmetic, so I will leave you to check that one. Okay. Let's talk about why this is 2. Why is the multiplier 2? Okay. So again, this is nothing new. You know how to use, I'll come back to this slide, don't worry. You know how to use t-tables. If I want to make a confidence interval, you look at the central area, right? If I want a 95% interval, 95% interval means the central area is 95%. If the central area is 95%, what does that leave the area in the right side? Anyone? If the center is 95, what's the area on the right? Center is 95. How many percent is the area in the right field? Just the right? 2.5. Good. So you go to the 2.5% column, column 3, the famous column 3, and go to 16 degrees of freedom, which of course is out of the screen. So you have to scroll. But if you scroll and look at it, I mean, you look down the table, you will find that at 60, you see a 2 there. That's why it's 2. Okay. Now I'll let you in on a pretty dirty little secret, okay? I mean, I don't know if it's that dirty, but if you if you have friends in statistics in other sections, not putting the professor down, but they learn a kind of simplified way where they are taught to use 2 for everything. See, so you know better. It's not always 2. Why do they do that? Is it a crime to use 2 always? No, it's just not so accurate, that's all. So I'm teaching you how to be more accurate. They put 2 in everywhere. You know the saying, if all you have is a hammer, everything looks like a nail. So all you have is the number 2. I'm going to put it everywhere, but you know better. You know how to use the table. So there are slight variations. It's not always 2. It's close to 2. Okay, just putting it out there. All right. So don't be surprised if your friends tell you, "Oh, I learned this 2SD method or something. I always use 2." Yeah, that's what's going on. Here it's 2 because it really is 2. Okay. How do you interpret any CI? You always start with the same phrase. We're 95% confident. Okay. So always say we're 95% confident. Oh yeah, of what? The difference in Laura mean this is the thing that we talked about, new men minus new women. New men minus new women is the difference in the long run mean ages of US men versus women. It's a difference. The difference between how old men are versus how old women are in the long run when they get their first gun is somewhere between 11 years and 8 years. Is this reasonable to you? Yes. What does it tell you? It means that men, on average, are between 11 to 8 years younger than women are when they get their first gun. That's the practical interpretation of this one. We're 95% confident that men, if you like, are between 11 to 8 years younger than women on average in the long run when they get their first gun. Are we doing okay so far? A lot to absorb, I know, but it makes a lot of sense if you think about it a little bit, all right? Okay, last one, and this is always quite easy. When can we generalize? Anyone remember? When can you generalize any result? If, when would you be willing to generalize the results that you have? Generalize. Anyone remember? I want to revise this concept from chapter 4. When are you willing to generalize the result? Very good. If the sample that you got the data from is random, very good. Very good. Okay? Don't forget that generalization is a feature of the sample's status. Was it random? Can you say that your sex is causing you to own a gun earlier in life? Can you make a causation claim? The answer should be Notice the big word cause there. Can you say that your sex is causing you to buy a gun earlier? Can you conclude that, in other words? The answer is no. Can anyone tell me technically why? You cannot, because this study is an observational study. Good. And what are observational studies? You lack the ability to what? Observational studies are studies where you don't have the ability to randomly assign the explanatory. Good. So I'll say this again. This is the conclusion that you make is not a causation one. Because this study is an observational study, you cannot make causation claims. But what does that technically mean? An observational study is a study where you did not have the ability to assign randomly the explanatory. What was the explanatory? Anyone remember? It goes back way to the first slide. What was the explanatory here? Remember sex. The explanatory good is the bucket variable. You put it, you can't assign sex. You cannot assign sex. Therefore, this study is an observational study. Can you say though? Can you say that the conclusion is men are associated with owning a gun earlier? Yes, you can. You should. This is a very strong result, but it's only association. As I've said before, being male is associated with at least 1 million things. This is one of them. Being male in the US is associated with owning guns earlier, but you cannot say that being male causes you to own a gun earlier. Is this okay? And that's the end of the slides. So what I plan to do today, and once we are done with this, we can actually leave early, and I'm confident this class usually can do that. So let me just pass out 1, 2, 3, this worksheet. As usual, try to do this on the sheet first, then we'll discuss on Scratchpad. Then we'll go, all right? Again, I will give you the data. I don't think the data is on your Scratchpad yet. Data Scratchpad yet. Not yet.
Well, it was taking it right. So we know they use random. Random assignment, there is no assignment. So you have to bring up some.
Okay, so if you look at our class data set, okay, the class data Scratchpad, I put it there. Payday versus mouse. Okay, so the candy type is here. The weights of the candy bars are there. Okay, you'll find it there. The data is there already. Here's what I want you to do. As usual, I want you to make 2 histograms for the data, not for the statistics, for the data, the actual data, like what I taught you. Email the histograms to me, okay? Don't print them out. Email the histograms to me. That will be okay. Just email the histograms to me. Now, before you start working on this, I will also ask you all to try to do the averages and all that on your own. Don't do it on this main page. I want to see if everyone knows how to do it on your own. So start your own Google Sheet and do it. Right? Don't do it on this page. In other words, keep this data there. The other thing I want to say is, I know I didn't ask this question. Is it clear what the explanatory variable should be? I didn't ask this as a question formally. Anyone? What is the explanatory variable here? What puts the candy bars into buckets? The type, yes, good. The candy bar type or brand should be the explanatory variable. Is that okay? So if you don't establish that, then all your work is going to be very confusing. So the bucket variable, the groups are what kind of candy bar are you? Okay. I have a question, nothing related to statistics. Do these candy bars still exist in this country? Oh, both do? Okay, because sometimes very established brands do die. So I'm just wondering. Okay. Is one of them have, okay, does one of, okay, I'm not a candy bar fan, so I'm not very, does one of them have a coconut center or am I wrong? Oh, which one is it? Oh, okay, thank you. Yeah, I'm not going to talk anymore. Once I talk about food, I get carried away. Okay, so uh, okay. Anyway, here's the data. All right, here's the data.
Define two parameters of this here. State the appropriate goal of technical buckets with this yes. So one of them is since it belongs to wait, so define two parameters in these terms. Wait, that's just what we did. That's just I think so. Or is that is that kind of like the long run proportion of the weight or something? You can do parameters. Let's just use it. So the null would be, I think, oh, wait, that's my previous assumption. Feel of feel feelings. So we have and then yeah. We're trying to sit there too. So but that'll be yes.
I have a question. I pressed a button and now I can't get rid of all these irritating formatting things. Does anyone know how to get rid of that?
Something is like it's like the like after thing. Yeah. Oh, she did that for someone. Oh yeah. Yeah, there's feelings like yeah. Yes. Yes. I think yeah. I think that's correct. I was saying the longer you eat the weight of monster that is more it's just that we're trying to figure out they really do right there. Yes. Okay. So it is. Right? Yeah. Do you know what it is?
Oh, wow, AI. Very good. Okay. If you are confident with what you have done for the first few, can I see some answers? Did the study make use of random sampling, random assignment, both or neither? We'll try to finish this whole thing. I think we can before 120. Just okay, so I'll make it a little bit easier for you. Random sampling, yes or no? Just highlight. Was there random assignment?
More or less than 20.
That's right. We did have a random sample. Good. We did have a random sample. But was there random assignment of the explanatory? Now take note. The explanatory variable is candy type. How can you randomly assign you shall be a payday candy bar? You can't do that. Candy bars are already made. All right. So you cannot randomly assign the candy type. Good. What does this mean? This means we can. What's the big word I want? Yes, we can generalize any conclusions we come to the greater population of candy bars. All right. Now we don't have we don't have random assignment or explanatory. This means we cannot. Can you finish the sentence? We did not have random assignment or explanatory. This means that we cannot. Anyone know how to finish that? This means that we cannot. That's right. We cannot make causation claims, which means you cannot say that being a certain candy bar is causing you to weigh differently or something like that. Good. All right. Define two parameters of interest. I'll start you off. You know that it must be a mu, right? Can you finish this? Mu what? Differentiate between the mu's. That's right. So you have mu payday. Let's define just one of them first. What's mu payday? Every time you see a parameter, what are the words that come out of your mouth? A parameter must always start with the word words. Give it a try. All right. Oops. You do one first, then you can copy paste and change the other one. This is the, oh, okay, you want to do it all at once? I actually recommend doing one at a time. Okay. The long run, yes, good. What is mu? Mu is always a mean. The long, and every time you have mean, you must have some quantity. What is of interest here? What is the data all about, honestly? The long run mean weight, yes. The long run mean weight of what kind of candy bar? Yeah, obviously, good. And you just copy paste that to define nouns, right? Same thing. State the null and alternative in symbols. Okay, so now that we have defined this, you can use a symbol. What does the null say? Mu payday. Can you finish this sentence? The null always says in this chapter that mu of one group minus mu of another group is very good. See, that is why I always teach slides first, then we do this, then we do other exercises. Good. Now, can you give the alternative though? What do you think? What does the alternative say? Did you catch which alternative you're interested in here? Did you catch that? Yes, very good. It's not greater than, not less than. Why? Because of the word different. So let's use this symbol, okay? Remember this one? Exclamation point equals, that's not equal to, right? It's very nerdy, but I don't care, right? It is. It's very, very computer science, very, very tech bro kind of thing, okay? But okay. Would a theory-based inference method be okay to use here? Why or why not? Can you tell me what you need to check? That's right. There are 20 observations in both. Okay, can you talk in terms of candy bars? Can you write this in a more specific? Uh, there are 20 observations for weights of. That's right. I'll just add one thing. Yes, there are at least. Okay. What is the other thing you need to check? And the what must be true about the weights of the payday and Mount candy bars? That's very good. All right. The weights are not too skewed. Very good. So I'm going to put a check mark or something. Oh, it's raining, right? Or going to. So, okay. Now you will be the judge of whether you think it's too skewed. You're supposed to send me an email on Instagram. I don't want you to plot the Instagram. I want you to show me that you know how to get histograms. Now, we will now tackle as pooled. This is your first time doing this, so take it slow. You know S pooled needs a bunch of numbers. So can I have people report these here? What is X bar payday? I know we don't need X bar right now, but we might as well get it out of the way. What is X bar mounds? Good, very good. I think the payday mean was 20.05, good. Mounds is 21.2, good. We also need S payday, S payday, and we need S mounds. We need this as well. We also need N payday and N mounds. These are easy. How many mounds chocolate bars were there? How many payday candy bars were there? Yes, this looks correct to me. Good. Now the pay, I think one is 22, one is 20. Am I correct? Okay. Yeah, thank you. Good. Okay, we are now ready. We have all the ingredients that you need to do as pooled. As pooled is SQRT. I'll help you out. Something times something square. Okay. Now to save on parentheses, don't do n minus 1. Just tell me directly what is the sample size less 1. Right? No one has asked me, do you need to do one group versus another first? For this, because it's a plus, it doesn't matter which one you do first. That's right. Were there 20 payday candy bars? 20 less 1 is 19. Good. And there's 22 mounds bars. 22 less 1 is 21. Good. See? And take the payday S value and square it. Take the mounds S value and square it. And then just add up the total sample size less how many. Very good. No, this class is definitely better than other classes that I've taught. You all really get it much, much more quickly. That's right. Now you just, I think it's ready for decimals. Just use it. See, okay, now do a good, thank you. Do a sanity check. Is this number between these two? Yes. So good. Did you get that? Okay. Now I would give you one word of warning. Again, I don't think this is going to happen in this class because this class really is quite good. I've had classes in the past. You know what they did? They had the right formula, but you know what they put inside? They couldn't put means. They put sample sizes here. They're doing that. I don't know. When students do things like that, I think their mind is not fully engaged on their work. They have the formula, but they can't differentiate between these things. They think it's okay, something to do with pay, something to do with bounds. I'm just going to put the sample size here. No, the sample size belongs here, not here. This S. But this class, this is not a problem, so that's good. So that's your S pool, very good. Show the numbers you would plug in to calculate theory T. Now you will notice that the way I did this sheet, it was not for this year, I'll tell you. This is a previous class in the past, which I taught. The class was finding it so difficult. I had to make a picture telling them where to put numbers in. Like, okay? So you are not at this level, but this is an old worksheet, I would say. But use it if it helps you, okay? Box minus box, okay? It looks really childish, but I was so desperate. I didn't know what to do. It's not easy to make this picture, I'll tell you that much, okay? So let's do it here without the picture, okay? You know that theory T is something minus something. You don't need to write the minus zero. Over SQ, well, something times SQRT 1 over something plus 1 over something. Okay, you fill in the somethings. Okay, like that. Again, all these statistics you will need. I think you will finally need the X bar thing. So I'm going to reproduce it here. That should help you, right? You can see directly. Just use the formula. You take the male, see, I said male, payday. Payday, I said do a payday versus month. Yeah, that's right. So payday minus month, like that. This is perfect, Do you see everything? X bar payday, X bar month, S pooled, sample size, sample size. Very good. To save us some time, I didn't ask you to do Desmos. I'm telling you, you should have obtained this. What is the DF you should use? Anyone? The DF, what's the rule? Show me the work for this. What is the rule? It's just to, yeah, there's a minus 2. That's right. So what should you write? All right. Thank you. The DF should be 40 because 20 plus 22 minus 2 is 40. Now, does 40 exist on our table? I believe it does. I think 40 is there. Let's see if someone can answer this correctly. What is the p-value range? Look at your t statistic. Your t statistic is 2.467, right? Your degree of freedom is 40. Can you identify the p-value range? There's nothing new here. P-value range is something you should be quite familiar with from older homework. Nothing has changed. See, I'm going to give you generic first. You want to do a payday versus mounts comparison? So you do a payday versus mounts comparison. Payday, mounts. Can someone give me the generic after the multiplier? That's right. Anyone? Just put your answer here, we'll discuss, right? Do you remember how to find p-value ranges from your T table, right? This is from the one mean discussion. This is not new, actually, right? I want to discuss can someone give me the generic formula for this? Just the words, right? After the multiply, what happens? Because the numbers are in, but I think there's one number that needs to be changed. So which one, all right? One number is not correct, okay? Okay, thank you. Let's check and see. You have a DF of 40 and a T of 2.467, okay? 2.467 and DF of 40. Where is 2.467? Okay, 2.467, I hope you can see, lies between this and this. Right? 2.467 lies between this and this, and we are on this row because of the 40 degrees of freedom, which means the column that you're looking at, one, two, three, column 4 and 5. Column 4 and 5. Now, if you look at column 4 and 5, 1, 2, 3, 4, and 5, that's the one. Okay? And I believe that is the answer that was typed here. Thank you. This is almost correct. You need to process this a little bit. Does anyone know what the correct answer is? This is not yet the correct answer. What is it? What do you need to do to this range to make this? Yes, well, I like how the one you multiply by 2. So you know what? What I will encourage you, I will copy this back. I want to show you the work. The original answer was this and this, right? You actually needed can anyone tell me why we needed to multiply by 2? Because the test was a two-sided test and the table only gives you the area in one tail. Look at the picture. So don't forget this. Okay? I mean, it's not a huge deal, but this is the kind of thing that can make you lose a point on an exam or something like that. Do you remember that the alternative was two-sided? Let's have a look. See? Did you see the not equal to 0? Alternative is two-sided. Therefore, you need to multiply the range by 2. But thank you. That's why I want to do this together with you. Yes, generically, you have payday minus mount multiplier s full square root 1 over what? Some n thing, right? 1 over n, I think we're doing, it doesn't matter because it's a plus, but we can be systematic, is payday, yes. Plus 1 over n mount. Good. There's only one thing. Check your multiplier. Is this correct? You want a 95% CI. So which place should you be looking at? Column 3, right? The famous column 3, 95% CI. And for 40 degrees of freedom, did you catch the correct multiplier to use? This is important. It's not 2. Did you see what it is? And we will end with this. It's 40 degrees of freedom and it's 95%. So your right tail must be 2.5%. Which number is it? Do you see it? Let's see whether this has been updated on Scratchpad. That's right. Do you know why it's 2.021? That's correct. Thank you. Why? 40 degrees of freedom, column 1, column 2, column 3, 2021. So you see? That's why your friends in other classes may always use 2. It's quite close to 2. The world is not going to end because I use 2. But it's not as accurate as it could be. That's why I want to teach you the T table. They don't learn the T table accent in the other courses, but I make it a point to teach it because I don't think it's right for you not to learn the T table. So, okay, thank you very much. I'll see you all next class, all right?